the moment that I start the streaming, I can already feel my body getting excited. It's becoming tense as well to perform well. Anyways, so today I'm going over the advent of code, day 9, and is it movie theater? Oh, okay, you're decorating the movie theater. Okay. And I'm going to solve the part 2. Did I? No, I didn't draw anything. We can probably draw some things here. So just to remember the question, we are giving a 2-dimensional grid, but the size is not really a thing. We don't have a size of it, but we are giving a list of red tiles, basically the positions of these hash characters, and these are in our input list like this. This is the test list, so it represents the x value and this represents the y value, and this is the 496 input values that we have at this moment. So the part 1 was basically choosing these 2 tiles somehow and calculating the areas and returning the largest area that we can make. So basically we were, for each tile that we have, we were checking all the other tiles, the other positions. We're connecting a rectangle, like a rectangle, right? Yeah, rectangle out of this by taking them as cross points like this and then calculating the area. It was fine, the logic was not complex, but here the logic becomes a bit more different. Now it says that all the tiles are either on the same, like the next position basically you have on your list. So like it won't have these diagonal shapes, all right? It can either go right or up or left or down. Once you are here, it can go left or down or right. Okay, left it is. It goes down here. You're checking left, nothing, nothing. Right, yeah, it is on here. And that kind of, so each position is kind of connected at this moment, which you can see here as well. We can perhaps see it here as well. So these are identical, and then this one goes here. Can it go like same? Let's see. Every red tile is connected to the red tile before and after it by a straight line of green tiles. Yeah. And in the end, the question asks you to have this shape, this shape. So these are the green tiles that are inside the red tiles and also in between them, right? So this was the outer circle, outer floor, outer wall, for example, and the inside is also considered to be a green. So here, then it asks you, the rectangle you choose still must have red tiles in opposite corners, but any other tiles it includes must now be red or green. So it can't be outside the wall that you've surrounded yourself. Yeah, I mean, let's have this screenshot and work towards it. I still, to be honest, I still don't have a working. Why are you so ugly right now? A bit better. Yeah. So basically, for example, this 2 has an area of 3 and it's a possible one. This 2 has an area of 1, 2, 3, 4, 5, 6. It's possible. These 2 has 3. It's possible. Basically, every other line that follows these things, these are all possible solutions. Okay? But when you have and choose, like, for example, this thing, it shouldn't be possible because this part of it is not green or red tile. If you choose this, not possible because this part is not green or red. This is possible, which has an area of 18. This is possible, and it actually has 3, 6, 7, 8. 8 times 3, 24. I think this was the biggest number, if I'm not mistaken. But let's, right, 3, 8, yeah, it's 24. What about this? Okay, we done it. So this thing, no, it's not possible. This thing, not possible. But like, you can basically draw these lines to every other thing, right? And if it is inside this area, you're good. Is there an easy way to understand this line is inside this area or not? It's difficult. Like, I think if there were to, like, if you can put, like, if you can put 2 positions to a method and you can provide the existing representation to this method. Yeah. Okay, there's a child crying, I'm guessing. Okay. Okay, I mean, if you're going through this path, what are the, for example, if you're going through this path, what are the things that you have to check? You have to check if this is within the line, this thing, and this thing, basically, like these 2 points, I think, you have to check if they are inside this area or not. For example, this thing, you have to check these things. For this and this, you have to check this and this. That could be like, for example, this and this, you have to check this and this. If they're inside, that should be okay in this case. I suppose. This and this, this and this, this and this, this and this, yeah. So whenever you identify 2 points, identify the other 2 points of this rectangle, and then try to check if this position exists there. But is it easy for us to check? For example, this point corresponds to, so I know this one was 7, 1. Okay. Let's do something like this is 7, 1. So, and this point, for example, this is 0, 1, 2, 2, and 0, 1, 2, 3, 4, 5, 2, 5, right? And this point is inevitably, you can check, so the difference of x value is, basically this will be the x value of this value, right, 2, and the y value will be 1. And this one will be the x value of this thing, and y value will be this one, 5. I'd like to clear this thing, yeah. Perhaps okay, so once you have that, perhaps there can be something like is-in method that has this position, and then it needs to have this representation of this grid somehow. Position and the grid, but I really don't know how can I represent this grid easily. So this is, position is very easy to see, right? For example, like is-in to 1 in our case, and the grid can be I mean, am I expected to make this representation? It's going to have a lot of space complexity. I'm therefore a bit hesitant, right? Should I do that? Then, I mean, if I'm going to fill this thing, I have to probably go from point to point. And then I have to, each line I have to fill this thing, this thing, this thing, this thing, this thing. And then after that, I can check if it's dot or not. That is definitely a brute force solution. And the space complexity is, it could be very high because you're going to represent this n by n grid basically, which can take huge area. Have another idea, I guess. What about the following? Constructing two lists that are, for example, here, we're going to, for the rows, for example, or like, yeah, for the x-axis, we have two, right? Um, two to, I don't know, or you can say like between two to, no, I think it's not two. I think this one was, so this was 5, this was 3. So on line 2, you can have 3 to 5, all inclusive. That's it. On line 3, you have some things, but they're not tiles, right? But you gotta involve them as well, like 3 to 5. For the 4 as well, it goes until this thing 7. For x-axis 7, we have 1 to 3. And not actually, it is actually 1 to 5 in the end, if you can manage it. And then 8, it will be the same, and 9, it will start from 1 to 7. 10 identical. 11, it's again identical, and that's it. If you have this representation, can we do this thing? For example, 2, 1. Is it, where is it? 2, 1. It's not here, so this is not in this list. But 7, 5 is included here, so it's okay. Basically, you're checking. For each x-axis, you represent which y-axis is that you have green and red tiles. Then you can probably construct it in this way. So you're starting from this one. Okay, it's 7, 1. And the next one I think was 11 one, this one. So you're saying, okay, the y-axes are identical. What can I conclude from that? I don't know, maybe you can also do like one has x-axis from 7 to 11. Maybe once you do that change, you can say this is it. And then once you have this thing, it's from x11 to 11 1 to 11 7. You can say like so this is, for example, y to x, and this is x to y. Eleven has from 1 to 7. And then here we have y to x. The y is same, the x is changing, so you can put so y is 7. At this path you have, but I don't know, it's not very easy to okay, I feel I'm getting stuck. Let me set up the timer, by the way. Start the counter for 15 minutes. There has to be a very good representation of this thing, or like, and how do you, or can you say like, let's check which coordinates are the closest to this thing? No, I don't think so. Like, let's think from the computer's perspective, perhaps instead of this visualization. We can go through, for example, we have 7 1. By the way, it doesn't really matter like which is x-axis or y-axis, it doesn't really matter. You can put whatever you want, but yeah, just for the sake of this, let's have this and this. 7 8 9 10 1 2 3 4 6 7 8 9 10. My ultra scientific measuring thing. Let's check it out. Oops. Don't change the thing. Maybe 2. No. Stay as you are. I don't want to change your size. Is there a rotate option? Anyways, so this is 10. So 7 1 is 9 8 7. This is 7 1. And 11 1 is, okay, is here. 11 7 is 9 8 7. Here. And then 9 7 is here. By the way, let me clean this thing. 9 7 9 5. Wait, yeah, should be more like this. 9 5. So this is 5. 2 5. 2 3. 7 3. And this. I can't even find the brute force solution. Oh. Somehow I need to create this two-dimensional thing, I think. That will be the brute force solution. You're gonna get the maximum x, maximum y. So it's like 7 and 11, right? So you can determine your area as 11, 7, and this. So this will be the grid that you can have. Oops. And then from there on you can say let's initialize this thing with dots, and then you can start from this position, and to this position you can make them crosses, and again for this direction you can cross, cross here, cross here, cross here, cross here, cross here, cross here. So eventually you'll map this thing to x and y's and stuff, and then from there on you can say probably traverse each line. Once you see the first x, continue the xing until you see the second x. So it's already marked here, but here you see it, and then you can do it, and continue, 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 and then in the very end you can say, okay, give me the number combinations. So 7 1 to 9 7, for example. What is the other points of this rectangle? So one of them will have the x value. So let's write it down. So 7 1 9 7. If we choose these positions to form our rectangle, the other positions will be 7 7 7 and 9 1, right? So this was 7 1, and this was 9 7, this was 9 7, this thing. So one option is 7 7 7. Yeah, this is 7 7, and this is 9 1, and then you're going to check if it's x or what, y or something like that. Should work. This approach. I think the space complexity will be the maximum of this, the minimum. Yeah, I mean, yeah, you can try to optimize it, but in the worst case it's going to be like one square space complexity, and the time complexity, you're going to iterate over this whole grid, so it will be also one square. And like, luckily we don't have that much input. Maybe this solution will work, by the way. Maybe. I mean, I'm currently happy to find the brute force solution. No, I don't know the optimal solution, how it could be. If I think about it, yeah, maybe I can find it. So the thing is, I'm in a bit time pressure right now, and you can see. I may have a time. I may have a time to implement the brute force. Okay, what are the things? Let's write it down. What are we going to do? We're going to create the grid with dots on it. So that's one, the step one. The yeah, I mean, for doing that, you can identify. You need to probably identify the sizes, right? I don't know. Maybe you can do, yeah, get max x and max y, and then create a 2D grid with it, and then you're going to iterate over it. Iterate over grid. Or I don't know, maybe directly put x to positions in grid, then iterate over grid. When x not seen, start. But the thing is, okay, we can have something like this. For example, we can have another point here as well as x, like 1 and then 2. It can have 4 as well, like one of them here as well. But how do you identify it from this thing? Maybe that's okay, by the way, right? Like if you are going through here, okay, maybe in this position, yeah, it will fail here. You, in this case, if you were to have, oh no, oh yeah, okay, if you were to have something like this, now the area will lie around here, and this line shouldn't be taken. Oh, that's too much. But okay, another option is, instead of directly putting x to positions in grid, iterate over the position. So for example, it's here. Have a look at the next one. Okay, it's on the same y-axis, so we're going to, between these two x, we're going to put x values to there. So 7 1 to 11 1, right? So these will be all x. and then this will be x, and then this will be x, and this will be x, this will be x. So once you have identified that, we're going to iterate over grid. Nothing here. Oh, first screen is set. Then go. Like if it's X already, it's okay. We're in the corner. Here, okay, green is seen. Let's populate until we see the next green. Yeah. Until we see the next green, basically, yeah. If you don't see, like, on the, like when you see the second one, and if you're out of bounds, you're not going to continue. But if it were continuing, you will not paint right here until you see the third one. Okay, so basically, like, it's like a switch. Switch on, paint, and switch off when you see the second one. So directly put follow the positions and mark them with X, including in between the positions. Okay, and then iterate over the when it's seen set flag, switch on, we can call it switch on, start painting until the next X scene, switch off, and so on. And then yeah, it will go on like this, iterating over this until search within the bounds, okay, boundaries basically, and then calculate the combination, not like the, yeah, retrieve combinations of positions, calculate the other 2 points of the rectangle and check if they are dot or X, right? Maintain them. If outside, let them have 0 or ignore. If inside, write them out or maintain the max area variable. Shall we write it directly here? Or is it not a good idea? I didn't like it, to be honest. Let's write it down in the regular place. It's going to be a bit long, I'm afraid. Um, let's reuse this thing. Get positions, position pairs, calculate areas. Yeah, I think we're going to extend it a bit. So once we have the positions, we're going to have the position pairs, right? But you also need to prepare the grid. Mm, it's going to have the positions, and yeah, that's it basically. Yeah, once you have the position pairs, you're going to update position pairs, filter position pairs inside grid. Okay. Maybe we can have filtered position pairs. Calculate areas, and then we're going to return the maximum of it. Prepare grid, let's do that. Def prepare grid. Position grids. Ah, sorry, actually, yeah, no, we are going to have this positions only. And then we're going to return a list of no strings. Max y. For in range max y, for in range max x, return, and then we're going to iterate over these positions and stuff. But for now, let's return this thing first, and we're going to print it as usual. I have to leave right now, unfortunately. Let's, yeah, I'll continue it.